result that we can do that also.
So
So
the
maybe I'll do
chain
that
rule,
now.
I
Okay.
saw the video, but it's like quite tricky, sir.
Okay, no, nothing tricky. Just you have to solve some questions, then only you will get it. But you don't have to solve anything. That much not required for doing physics. Okay. So what I'll do here, I don't know what is the differentiation of e power minus x is. So I will assume minus xst. Why? Because in that case, y will become e power t. And then I know a standard result that I can find dy by dt, correct? Differentiation of y with respect to t we can do if, so that is e power t, correct? So we
Yes,
are going to
yes, sir.
write down dy. So one way is this. So we'll write down dy by dx as dy by dx. Just we are going to multiply it with dt dt. And doing that thing feels weird because like how come it is correct, man, that I can change the denominator? We can because however we find them out at the end of the day they are ratio like p by q into maybe r by s, no? So if I exchange the denominators, even though now after exchanging denominator, P by S can be having different identity. R by Q may be having different identity, different from whatever was of R by S. But doing such thing is totally fine, no? The same way here, I'll exchange the denominator so we get dy by dt into dt by dx. So in this step, I'm utilizing the property of dy by dx being a ratio as well. So it's like this guy has got dual nature. It is an operator as well as ratio, both at the same time. When I need his operator properties, he will do the job of operator. When I need his ratio properties, we'll treat him like ratio. It's like a driver who is also like a security guard. Sometimes security means like bodyguard. So some problem happens, he might behave like a bodyguard. Maybe if driving requirement you have, he will behave like a driver. So differentiation of y with respect to t, we know it. No? So after that, we replace y in terms of t and here t in terms of x. So differentiation of e power t will be with respect to t power t. Differentiation of minus x with respect to x is minus 1. So answer will be minus of e power t. So it's going to be e power minus x. Clear, no? Clear, no?
Yes, sir.
So basically, you will be doing this thing dy by dx of e to the power ax plus b if I give you. That's going to be a into e to the power ax plus b. Okay, then. So we'll see something called as increasing function. So did I discuss increasing function, Saktivel, last class?
No, sir.
No, no. Man, discussing these things is so boring for me. I don't know because I've told it so many times, and it's not physics, no, it's maths.
Sir, this is the first class now, sir. We are doing this.
No, we have done different. Yeah. No, no. I have taken backup for other people also. No, you came like very late.
Okay, okay, sir.
2 times I took already backups and all. I thought, okay, I'm done with backup now. We'll be doing interesting physics things. So, but still, no problem. But it is essential what to do. So when I say a function is increasing, like for example, I tell you that we have got a function which is increasing in some interval, then we select any two numbers, any two things from such any such interval when where it is increasing. Let's call them as x2 and x1, and such that x2 is more than x1. And what we find, the output of the function at input x2, we call it as y2, which is like f of x2 is bigger than y1, which is the output when input is x1. So for every such values from a certain region selected, what kind of values, such that one is bigger than another, then for the bigger one, the output must be bigger than the output for the smaller one. So on increasing the input, so if I increase the input and if I find output also increasing, then we call it as increasing function. Like increase the number of study hours, maybe marks might increase. No? So I can give you an example of something you know it already. If I consider x to be taken from this region more than 0, less than 90, and that is also written like this. I hope you know this thing, no? This way to write things. X belonging to 0 comma pi by 2 small or open bracket we have. It means x will not be equal to 0 more than 0. Correct? And x will not be less than will not be equal to pi by 2, less than pi by 2. And the function I'm talking about is sin x. So you give him any two values in this region such that one bigger than another. For the bigger input, the output will be bigger. Like for example, if I give him x2, which is 60 degrees, but 60 we don't write, we write pi by 3. And if I take x1, which is like 30 degrees, so the output at 60 degrees, is it not bigger than output at 30 degrees? Correct. So for any two such values which are in this order, their output is also in same order. So for such function, what happens? If I find the slope, it will be positive because what slope of a function at any point means, or what dy by dx of any function at any point means. It means really this thing, no? I'll write down f of x plus delta x minus of f of x by delta x, where delta x is very, very small. Small delta x, we can represent in using dx also. So informal way to write it down can be this also, no? X plus dx, output at x plus dx minus output at x divided by that tiny change in the input, that is dx. So what kind of dx we have selected for talking about dy by dx? That was more than 0, correct? If dx is more than 0, so tell me x plus dx is more than x or not? More than x. So, and if function is increasing 1, then the output at bigger input is going to be more than output at smaller input, no? So f of x plus dx will be more than f of x, correct? Correct, no? It
Yes,
means
sir.
f of x plus dx minus of f of x will be more than 0. And you see, this is more than 0, and I divide him with something which is also more than 0. So that thing will be more than 0 or not. So for a function to be increasing in an interval, see again, a function is increasing does not mean like it should be always increasing. Like a profit of a company can be increasing in one quarter, maybe in next quarter it might be decreasing. Who knows? Correct. So same way, a function when we talk about increasing or decreasing, sometime a function can be always increasing, sometime maybe not, sometime increasing in one part, maybe decreasing in some another part. So for a function to be increasing in whichever region, the dy by dx or the slope must be more than 0. We can understand this thing maybe through graph also. If I draw a function which has an increasing trend, it may be looking like this, no? And you see, here I take a value which is input x1 and there the output y1. Then I have taken a location where input is x2, which is bigger than x1, and there output y2 is bigger than y1. So basically, you can totally look from the graph as x increases, what happens to the y? That too increases. And if I drop tangent anywhere, what kind of angle tangent is making, you can check out. You can like totally see that. The angle made by the tangent everywhere is acute, is it not? So slope is like one way to find dy by dx is like another way to find the slope only. So theta less than 90, so like tan theta is going to be positive, so slope positive. So dy by dx positive. Okay. So to save time, the opposite of this thing I will tell you without explaining. Maybe you can connect the dots on your own. So if you have a decreasing function,
Sir, can you explain that black color written again, sir, once again?
which this part, yeah, I'll explain. See, dx is more than 0. If I take, what is dx is change in x, and suppose I did do a change in x which is positive. Okay, so dx more than 0. So tell me, x plus dx is going to be something more than x or not?
Yes, sir.
And if function is increasing, then the output at bigger input will be bigger than the output at a smaller input. So among x and x plus dx, the bigger thing is x plus dx. If I'm telling if function increasing, then the output at x plus dx will be more than the output at x. So f of x plus dx should be more than f of x. So if f of x plus dx more than f of x, then what will be f of x plus dx minus f of x? Positive or not? Positive. Now you check out what is dy by dx is. It is having something in numerator which is what? Positive. Something in denominator, what it is? Positive. So what really he must be then? Positive. Clear now?
Yes, sir.
Yes.
Clear. And what numerator contains? Change in y. So if I increase x by dx, then the change in y must be positive. Then only I can say, no, the output is increasing. On increasing the input, which is x, y the output must increase. And if it increases, what really you will write him down as? Final output minus initial. Final bigger than initial. So change must be what? Positive in output. Clear, no?
Yes, sir.
So tiny change I do or big change I do, that doesn't matter. If I do some change which is positive, the input increases by tiny amount, maybe by tiny amount, but increases, no man. So even f of x plus dx output, or the value of f of x plus dx is slightly more than f of x. So what? Slightly or whatever, it is more, means it will be positive. Clear, no?
Yes, sir.
Okay. So maybe just I will tell the reverse of this, what decreasing function will be. The one on whom I increase the input, but output decreases. Like increase the screen time, marks will decrease. So if a function is decreasing in a region, then x2, if I give him as input, and x1 if I give him as an input such that x2 bigger than x1, then the output at x2 comes out to be smaller than output at x1. So dy by dx of such function which is decreasing in an interval will be negative. So check out the example of y equals cos x. So if I consider x belonging to 0 comma pi by 2, what is the dy by dx he has? Minus sin x, no? And if x lies in this region, what really sin x is? Positive. Sin x guy positive. So what will be minus sin x guy? Negative. And what minus sin x is also? Dy by dx. So dy by dx negative. So, and you can totally tell what is the Output will be if I keep on increasing x. So take x0, y1, x30, y1 by 2, x90, y0. No? So on increasing x, the output, the y decreases. And the graph of such function, wherever it is having decreasing trend, maybe it might look like somewhat like this. So here is an input x1 where the output you see is y1. Here lies another input x2 where output is y2. So totally, is it not satisfying this x2 more than x1? Then the output at x2, which is y2, is less than the output at x1, which is y1. No? And dropping a tangent in such interval, you will find the angle made by it with positive x will be obtuse. Obtuse the angle is, the slope which is tan theta will be negative, and alternative way to find slope is the dy by dx. Both will give a same answer, whether I find tan theta value at such some location or whether I find the dy by dx value at that location. So dy by dx will be negative. Clear? Next thing is
Yes, sir.
something that is called as maxima minima. Maxima means a point where a function attains a maximum value, and it is not compulsory for every function to attain a maximum value. If some function attains a maximum value at some place, that point, that coordinate altogether is given a nice name, maxima. Okay, we'll see more. First of all, if you find a function which is always increasing, just 1 minute, iPad has hanged. Give me a second. Yeah, now working. Always increasing function never attains maxima. For a function to attain maxima, suppose if I give an example, like weird kind of example, but still maybe you will understand. Suppose if you have a hypothetical bank account which will be running forever, and there's a artificial intelligence, maybe a robot, something which will be living till eternity, is adding money into that account daily, some amount of money. So tell me, if I ask you when the balance, account balance, or the money in the account will be maximum, never know, is it not? Because every other next day, the money will be more than previous day. Every next day, money more than the previous day. So never ever I can pinpoint a day like, okay, this day the money was max, correct?
Yes, sir.
So every time he was adding some money in the account, but one day it started withdrawing money. Then tell me, okay, but so I'll give an example of always increasing function. So suppose if I give you y equals e to the power 3x plus 5, find dy by dx. That's for an exercise. Or y equals e power x. Or anything, maybe in general, I'll write down y equals e to the power ax plus b, where a is positive, constant, okay, not negative. Then what will be dy by dx? Dy by dx will be a into e to the power ax plus b. Like for example, y I give you as e power x, even directly that chi, dy by dx will be e power x. Tell me, can you think of any x, the one which can make him negative? Whom I have to, which thing I have to make it negative? This entire thing, e power x. So nothing you can give to this e function, to its, the thing that is to be placed in its power, that can ever make it negative, no? Correct? So what kind of e power? So same thing it is going to happen with this one also. A is positive only, and the thing multiplied with it can never be made negative. So dy by dx is positive, but if I ask you where positive, what you will answer? Always positive. So dy by dx is always positive, then what really it means? That it is always increasing function or not? So this is like famous example of an always increasing function. Maybe I'll tell you the graph of this one, just like that. If you remember it good, if not, still good. You'll be seeing this graph in chemistry also. Before you might be seeing it in physics. But so graph of this thing is going to be like this: y equals e to the power x. So it is going to be cutting off the y-axis where x is 0. Where x is 0, what is the value of the y will be? 0, comma 1. And as you keep on moving towards minus infinity side, so what will be e power x value will become when x is maybe minus infinity? Just a thought experiment. E is a quantity more than 2, no? And so maybe I'll write down as 1 by e power infinity. And something more than 1, if you give him a power infinity, means you multiply him infinite times with him itself, no? Like 2 power infinity means what? You have multiplied 2 infinite times. What do you expect answer to be? Infinity only,
Yes, sir.
correct? So it's going to be 1 by infinity, and what it is? 0. So as the more and more x becomes nearer to minus infinity, the more and more y will be becoming 0. So that is why this graph is drawn like this. It's like trying to touch, trying to touch. And you see, it is always increasing or not. Drop tangent anywhere. Everywhere the angle made by the tangent, you will be finding it to be acute only. Okay, just a second, man. Before I tell you anything further, there's something called double differentiation thing I have told or not. For example, if I tell you y equals sine x, suppose. Okay.
Sir, in
So
general, the differentiation of e power x is e power x, no, sir?
yeah, correct, correct. Yeah, there is nice thing, weird thing about it. No, rate of change of that function is equal to himself, and weird, no? You do a tiny change in x, and because of that, the tiny change in y, you measure it. Place that small change in y in numerator, that tiny change in x in denominator. That is equal to y again, man. Weird kind of function. Okay, so y equals sine x. If I ask you, find dy by dx, what you will do? You will be writing dy by dx of sine x, which is cos x. Now, if I ask you, find differentiation of the thing you got upon differentiating y again. So you differentiate dy by dx again. So what it will be? Dy by dx of cos x. that will be minus sin x. Like another example, I give you y equals maybe x cube. So dy by dx will be like that. Directly you can write 3x square. D square y by dx square means you differentiate the dy by dx, because upon differentiating a function of x, what do you get? Like not like goat or cow out of that, some another function of x. So you differentiate that again. So that is going to give us 6x. Correct? So whatever it is, you get the meaning what really it means by finding double differentiation of anything, doing the process of differentiation on it two times back to back. Something I'm going to tell you. So just see, I'm telling enough things so that we can do physics. I'm not. There are so many things that could be told if math teacher will teach you this thing. So even something interesting, but not going to make you good in physics. It's boring for us.
Sir, will this come in 11th max, sir?
No, that is the problem, man. 12th maths. Maybe 11th maths also in Ellen you will see. Okay. So what to do? Our CBSE people are so intelligent. Shape of a curve. Suppose if I draw a curve and you have to tell me what kind of shape it is having. It's like speed breaker, no? So suppose if I take a small part of this curve anywhere, okay, wherever I have to decide what shape it has, I will take a small part of so of that curve around that point. Which point? The one where I want to check out what kind of shape it has. So any small part of a curve like this one, is it not belonging to some circle? Some circle, no? So whatever circle it belongs to, how to find out which circle it belongs to? Literally, you extend him to make a circle out of him. And then you will find the center of the circle of which this small part belongs to is lying here, no? So if you find the center of the circle of which a small part of a curve is a part of, lies below the curve. If the center is called as center of curvature. Okay. And the radius of the circle, the one we have drawn at that point is called as radius of curvature. Got the point of what we have done? So wherever I have to decide what kind of shape a curve has, we take a small part of the curve around that point and we make a circle out of it. And then that circle will have a center somewhere, wherever it is, that is called as center of curvature. Curvature is like full form or full name of curve. Like who will say curvature? So lengthy, so we say curve. So name hence comes center of curvature. And it is radius of what you will call uh, height, radius only, but radius of what? Maybe curve here, so curvature. Clear, no? So if the center of the curvature lies below the curve, then we say the shape of the curve there is concave down. So you see the caved part, like concave mirror, if it is, then the shiny part, the polished part, the reflecting part of the mirror will be the caved part, no? Not like the caved one, no? So this is having that caved part lying below, so we call it as concave down. So if the center of the curvature lies below, then the shape of the curve is called as concave down. And wherever the shape of the curve is concave down, what we find, the value of the double differentiation, ask your math survey or maybe think about it or don't think about it, but you must know it. So, and you can't forget it when few things are like you can't forget. Generally, we relate going upward as nice thing happening, like he's going up in life. That does not mean that his life is might be becoming bad. It will mean mostly means life will be becoming good only. So positive going up is or upward is related as positive. And down generally people relate it as negative. So concave down means like negative. So double differentiation value in that part will be negative. I'll give an example also of a curve, the famous curve of sin x. So sin x curve is going to look like this. Why? Because we have plotted the curve somehow. So this is first one is 0 to 180. This region you check out. Totally you can tell the curve is concave down. So y equals sin x is the function. Find the dy by dx, which is cos x. Find d square y by dx square, means find differentiation of cos x, that will be minus sin x. If x belongs to this region 0 to 180, we know, or if you don't know, then you know now, sin x is more than 0. So what really minus sin x will be then? Less than 0. So what will be the double differentiation then? Negative. So what is the shape you find there? Concave down, no? So same way, if the curve is going to look like this, or if the center of the curvature lies above, we call it as concave up. And wherever the shape of the curve will be concave up, you can't forget, no, up positive. Clear, no?
Yes, sir.
Okay. So for a function to attain maxima, it must increase, then it should decrease. Always increasing will not be giving him a maxima. So it must increase and then it should decrease. And if it increases and decreases, it will end up giving a shape that will be concave down. And you find the point where it is at having the peak value, there if I drop a tangent, you will find him to be parallel to the x-axis, which means the slope of the tangent will be 0 there. So it means for maxima to occur at any point, what will be the conditions? That slope or the dy by dx must be 0 and the shape must be concave down. So you must remember it other way around. That you can't forget, for a function to attain maxima, it should increase, then it should decrease. So wherever it has stopped increasing and started decreasing, at that point we attain a peak value. Like up to this day, money was added in the account. And then after this day, money was withdrawn from the account. So the day we stopped adding money and started withdrawing, that is the day the balance will be maximum, no? So that's for having this thing to happen, the shape will end up becoming concave down. And concave down means double differentiation in that region will be negative. I hope clear, no?
Yes, sir.
So minima means a point where a function attains a minimum value. and always decreasing function never attains minima. An example of always decreasing function can be y equals e power minus x. You see, his dy by dx will be minus of e power minus x. And you see, e power minus x minus it is in power. He can never be negative, no? So this quantity is always more than zero. So minus of that will be what? Always less than zero. So his dy by dx is always negative. So he is an example of always decreasing function. And the graph of this one is going to be looking like this. Y equals, these are famous graphs that is like general knowledge kind of things. Everyone must know. So you see, it is cutting the y-axis where at 0, comma 1. And when x is going to be very, very large, like plus infinity, what y will become? Y will become e power minus infinity. And what it is? 0. It means the more the bigger value of the x will be, the smaller he will become. So if x becomes infinitely big, y will become infinitely small, means what? 0. So for a function to attain minima, always increasing, always decreasing will not do the job. For it to attain minima, it must decrease, then it should start increasing. And wherever it has stopped decreasing and started increasing, there the function will be having its lowest point. And there again, you will find the slope to be 0, means dy by dx 0. But the shape of the curve it will generate because of having a minima is going to be concave up, no? So the condition for minima means condition of minima will be at whichever fine point you have minima, dy by dx should be 0, and double differentiation. So you should not be reaching this result directly. You should know that shape of the curve must be concave up. It's like minima guy, he was decreasing, so he became poor. So he has to collect water, the rainwater, because he can't afford to buy water. So what kind of shape of the curve it has? Concave up. So concave up is the shape of the curve. So double differentiation must be positive. So these two things must be satisfied simultaneously for having a minima at a point. So whatever things done here clear, no? And
Sir, can you explain that e power minus x graph, sir, once again?
that graph, I don't have to explain. You know this is the graph. That's all.
Yes, sir. Sir,
Why it is
and
the graph? Very soon, math sir will discuss. Okay.
sir,
And
and
I can tell also. I can tell also slightly. You see, at x0 you put what y will be 0. Y will be 1. So the point where it cuts y-axis is 0, comma 1. Now, what is the dy by dx is always negative, no? So you see everywhere what kind of angle the tangents are having with the positive x. Obtuse or not? Correct?
yes, sir.
Correct, no? And
Yes.
as I give him an input which is very, very large, means x equals plus infinity, what y will become? Minus infinity. E power minus infinity, what it is? 0. So it is like something like that only, no? If I give him x to be minus infinity, he becomes 0. But he is y equals minus e power minus x. So how to make the numerator to become minus infinity when x is infinity? So it is like theoretical thing, not like literally it will get infinity. It means the more x is near to infinity, the more y will be near to 0. So this curve will be tending to touch the x-axis where at infinity. So the x-axis is an asymptote to this curve. If asymptote thing is over in your math, if not, sir will discuss. But you get the idea. The graph is making sense, no? To be like this. And do is
Yes,
double
sir.
differentiation also. So dy by dx, it came out to be e power minus x. Differentiate it again. Double differentiation is going to be equal to e power minus x. And what it is? Always positive or not? Always positive means what kind of shape of the curve should be? Always concave up. Clear, no? And what kind of shape you can tell? You can't say like concave down, no? However, it is more concave up type. No? Clear, no?
Yes, sir.
Okay. Okay. Then. So algorithm goes like this. If I give you a function y, a function of x, you find the dy by dx, which will be some another function of x. Equate it to 0 to find the values of the x where dy by dx is 0. And if at a point where dy by dx is 0, and at that point, if double differentiation is negative, it means shape of the curve is concave down, means it is a point of maxima. If dy by dx is 0 at a point and double differentiation is positive, means shape of the curve concave up, means minima. And in case if none of this happens, maybe dy by dx is 0, but double differentiation is also 0. So then we say it is neither a point of maxima or minima. And sometimes it is a point which is called as point of inflection. And what is the meaning of point of inflection is, I will tell you through an example of simple curve of sin x. So this is the graph of y equals sin x. So check out these points, which is x equals to pi, or maybe check out the point where x is equal to 2 pi or maybe 3 pi, like that. Just before x is equal to pi, you see what kind of shape it has. This red part, concave down. Just after x equals to pi, what kind of shape it has? Concave up, no? Then concave down. Just before x equals to 2 pi, concave up. And just after x equals to pi, concave down. And we know what is the double differentiation of sin x is? Minus sin x. So at x equals to pi or x equals to 2 pi or something like that, 3 pi or any integral multiple of pi, we know sin x there is 0. Sin x 0 means double differentiation of sin x, which is minus sin x, will be 0. Correct? And what is happening there? There the shape of the curve changes. It can be changing from concave down to concave up, or maybe concave up to concave down. Eh, Anyone. So what really the meaning of point of inflection is? The point where the shape of the curve changes. Okay. So just do one question only, like means literally one question. To open that mathematical tools module. Do you hear humming sound or you don't hear any humming sound?
Sir, I don't hear anything, sir.
Okay, then good man. Because I hear. We can do this question. Y equals x cube minus 6x square plus 9x plus 15. Find the points of maxima and minima of this function. Y equals x cube minus 6 square plus 9x plus 15. X cube minus 6x square plus 9x plus 15. Find the maximum and the minimum value of the function. So try from whatever you've understood. I'll also get a break in during 2 minutes. Okay. In the meantime, you try. I will take a break. So try this thing, man.
Okay, sir.
Okay, got anything? So to find dy by dx, so that will be 3x
3x.
square minus 12x plus
Yes.
9, no?
Yes, sir.
Equate it to 0, find the roots. Or you found the roots, then tell me.
So it's 1 and 3.
1
Right.
and 3.
And find d square y by dx square. That will be 6x minus 12, no?
Yes, sir.
So at x equals to 1, we'll find double differentiation value. And that will be 6 into 1 minus 12
Minus 6.
minus 6. And at x equals to 3, d square y by dx square is going to be how much? 18 minus 12, which is just we want to know positive or not positive. It means at x equals to 1, we have got these two things satisfied. Dy by dx 0 and d square y by dx square is going to be negative. So it is a point of maxima. So how to find the maximum value? Once I know at what input maximum output is this going to be at input 1. So find the output when input is 1. So maximum value will be value of the function when input is 1. So that will be 1 cube minus 6 into 1 square plus 9 into 1 plus 5, whatever it is, you can find it out. Same way, at x equals to 3, you have got minima happening, no? Because at, just a moment, at x equals to 3, dy by dx is 0, okay, and double differentiation is positive. So minima occurs. So to find minimum value, you plug the
Yes.
value of the input 3. Whatever the output is, that is minimum value. Clear, no? Clear, no?
Yes, sir.
Okay, then.
So, sir, for x equals to 1, how did you get the maximum, sir?
Because what is the condition for maxima is slope or dy by dx should be 0 at that point, and double differentiation must be negative, no? So we found the double differentiation value, what it is. Tell me, minus 6, no?
Yes, sir.
So double differentiation negative, differentiation 0 means maxima. Correct?
Yes, sir. Yes, sir.
Okay, no? Okay, then now, okay, now we will see integration. So not much you have to know, just you have to know what is integration. How to do simple ones, very simple ones. So first we'll see what really is indefinite integration. See, differentiation is an algorithmic process, but integration is like guesswork, man. For example, if I give you, we have a function y, a function of x, and maybe it is x square. So what will be its dy by dx? That will be something which is 2x, another function of x. No? So on differentiating f of x, we get some another function of x. Maybe I call it as h of x. So I'm telling you, okay, we have a function which I don't know, but his differentiation is 2x, I know. So can you tell me what was that function whose differentiation is 2x? So however you answer it, you can like see that, okay, it must be 2x because on differentiating x square only I see 2x. So somehow if you found x square given what differentiation of x square, so finding out the function when the differentiation of a function given is called as integration. So you can call indefinite integrator says, or one of the meaning of integration is, one of the meaning is reverse differentiation. Okay. So, so just I'm telling enough, pair enough so that we can start doing physics. There are more things to integration than whatever I'm telling you. So the symbol or the operator we use to do the integration is this operator. So what function I'm going to integrate here? H of x. And with respect to which variable I'll be performing the integration. With respect to which variable, it must be x only. So to write that, we'll write dx. Dx written here means we have to perform the integration operation with respect to the variable x. And what it will be giving us? F of x. So if I have y which is f of x, or maybe I'll write if dy by dx of f of x is h of x, it means if I integrate h of x, I will get f of x, but I will write something like c, which is called as constant of integration. Why? I will tell you now. Now, for example, if I tell you that y is x square plus 3, so what will be the dy by dx? Dy by dx will be 2x. So 2x, once you see, you will guess, okay, it must be x squared. That's why its differentiation became 2x. So what is given to us? Dy by dx is given to us. What is y? We don't have any idea about it, man. Like, we don't know anything. This thing is hidden. We don't know. So your best case will be like it is x square. So y must be x square, but there must be some constant which we are not aware of, no? So during the process of differentiation, the constants will be like killed, no man? Because differentiation of constants will be 0. So that's why I will say that y must be x square plus some constant that we don't know. If there was no constant, means c, that constant I will write down as 0. So I hope you got the point now. When we do this kind of integration, why we keep a constant in there? Correct, to remember the dead constants which are killed during the process of differentiation. So that's why we know the answer, but we don't know the answer. We know it is x square plus something. So we have an answer, but not like exact answer. Like it is x square plus 3 it was, or x square plus 5 it was what it was added with x square. We don't have any idea. So we have the answer, we don't have exact answer. So we don't have a like definite answer. So the name came indefinite integration. I hope you got the point what really indefinite integration is and why we put a constant c there. Clear, no?
Yes, sir.
Okay then. So I will write the table of integration that you have to remember for whole life. We can prove it also. X power n will be having integration x power n plus 1 by n plus 1, where n can be anything except minus 1. Okay. We cannot use it for minus 1. That you will know why. For time being, just I'm telling you. N can be anything, just not minus 1. Integration will be plus c. That is always there. Integration of sin x is cos x plus c. Cos x is minus sin x plus c. Secant square x is tan x plus c. Secant x into tan x. secant x plus c. Then cosecant square x is minus cot x plus c. Cosecant x into cot x is minus cosecant x plus c. Then log, then 1 by x or e power x integration is e power x plus c. 1 by x integration is log x, which log the one whose base is e. So one way to write it down is just you write log x. If nothing mentioned in the base, in our subject, we will understand it is having the base e. Or it can be written like this, log ex or ln x plus c. So how to prove this thing? Nothing to do. So cos x differentiation is what? Sin x. So sin x integration cos x. As simple like that. Minus sin x differentiation, if you do, you will find it is cos x. So cos x integration minus sin x. X power n integration x power n plus 1 by n plus 1 differentiation will be x power n. So x power n integration is that. But when n is minus 1, what really it becomes? It becomes x power minus 1. And what it is? 1 by x, no? So log x, if I perform differentiation, we get 1 by x. So 1 by x integration must be log x, not anything other than that. That's why when n is minus 1, it is entirely different thing. And also when I use n minus 1, here I get an undefined answer. So it's like math telling you don't use this formula when n is minus 1, because this is a wrong thing to do. Because when n is minus 1, that thing is really 1 by x, and which is the differentiation of log x. So differentiation of log x 1 by x. So integration of 1 by x must be log x, not anything else. Okay. I hope clear, no? Clear, no?
Yes, sir.
One more table. We can prove the results in this table also, but still I'll write the table. So here a and b are some constants. So if you come across ax plus b to the power n, again for every n except n not minus 1, it will be ax plus b to the power n plus 1 by n plus 1. Extra thing you do is you divide him with a or multiply it with 1 by a. Sine of ax plus b will be I wrote wrong, man. Sin x is minus cos x is sin x. Differentiation of minus cos x is sin x. Because differentiation of cos x is minus sin x. Okay, no, a mistake I wrote wrong. So sin x plus b differential integration will be minus a cos minus 1 by a cos ax plus b plus c. Cos ax plus b integration will be 1 by a sin ax plus b plus c. Secant square ax plus b will be 1 by a tan ax plus b. E power ax plus b will be 1 by a e to the power ax plus b. 1 by ax plus b will be 1 by a log of natural log of ax. Series so stupid. Okay. And we will need one more class at least, but at least we started what is integration at least, no man. Correct?
Yes, sir.
Correct. Just tell me. So after this, I will tell you like how to get these things. There is integration by substitution. But maybe read those things or don't read those things. Just you read what is definite integration on your own. Or maybe one more half an hour class. I will take some time and we'll be done with these things. Okay. Okay. No?
Yes, sir. Yes, sir.
Okay. Okay. In the meantime, this much will be enough. Okay, because 7:30 again you have to join for relative motion class also, no?
Yes, sir.
Okay then. So we'll end the class now. Okay then. Bye bye. See you in 7:30 class.
Sir, one very small doubt, sir.
Tell me, yeah.
Sir, you have given one question, no, sir.
Which one? This one.
Yeah, sir. Sir, we
Yeah,
have found the roots, no, sir.
yeah, correct.
Sir, but what to do with that roots? Like,
Yeah, so
what
no,
will be
no.
the
Let me repeat. We are finding the values of dx when dy by dx is 0. So at two possible values of the x we got where dy by dx became 0. One, you only told me one is 1, another is 3. It means wherever dy by dx 0, two possibilities we can have now. And without drawing the graph, if I tell you, okay, I have a point where dy by dx 0, it can be a point which is maxima or it can be a point which is minima. We don't know which one. So again, we find double differentiation. So differentiating a function of x, what we will be getting again and again, some another function of x. No? So at x equals to 1, what is the double differentiation is? Negative. And along with that, what is the differentiation is at x equals to 1? 0. And that is the condition for maxima. Means at x equals to 1, function attains a maximum value. So how to find maximum value? If I tell you sine is maximum at x equals to 90, how to find out maximum value of sine function? You plug 90 in the function, no? You find sine 90, which is 1. Same way here. Maxima occurs at x equals to 1. What you will do? You put x1 in that function, find that maximum value. Clear, no?
yes, sir. Yes, sir.
No, not clear, no?
So the no,
So
sir.
at
That
x equals
uh,
to 3 is satisfying the condition for minima. It's dy by dx at x equals to 3, 0, and double differentiation is positive. Why? We found it out. We found the function which is double differentiation. In that function, we plug x as 3. We got double differentiation positive. So at x equals to 3, both these two things are satisfied simultaneously. Dy by dx 0 and double differentiation positive. So what it is? Minima. So at x equals to 3, minima occurs. So you plug x as 3 in this function, whatever the output it is going to be giving you at x equals to 3, that is the minimum value. Clear, no?
yes, sir.
Okay. 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 We'll end the class. Bye bye. See you at 7:30.
Yes, sir. Thank you, sir.
Bye bye.